quiet archive record. Tonight, we cross into a quiet world where the dark is safe and the story is enough. Let the day fade away and quietly slip into the deep. Unidentified submersible objects, often shortened to USOs, are reports of unknown craft or lights that appear in the ocean, move through water at unusual speed, or pass from air into water without slowing down the way normal machines do. The stories show up in Navy logs, pilot reports, coastal police notes, and in the files of researchers who track unusual events. Some cases are old, filled with rumor and missing records. Others are recent, with radar tracks, infrared video, and trained witnesses. Skeptics point to mistakes, myths, and the human need for patterns. Supporters point to repeat details and to events that seem to break the limits of known submarines, drones, and aircraft. Tonight, we go through the physics of unidentified submersible objects. To make sense of the strongest claims, it helps to separate the ocean from the mystery. The sea is big, dark, and hard to measure. Sound bends, light bends. Currents move objects without warning. A person can see a bright light on the horizon and have no good way to judge its size or distance. A camera can compress depth and remove the clues our eyes use. A radar can show a target that is not a solid craft at all. So the first step is not belief or disbelief. The first step is building a toolkit. What does the ocean do to sensors? What does the atmosphere do near the surface? What kinds of motion are possible for known machines? What kinds of motion would require a new method of moving through water? There is a second reason USO reports draw attention. Most advanced air vehicles we know of still struggle in water. Water is about 800 times denser than air. That density makes water good for pushing against, which is why boats can move without wings. But the same density creates strong drag. A fast object in water meets huge resistance. The pressure also rises quickly with depth. At only 10 meters, pressure is about twice the pressure at the surface. At 100 meters, it is about 11 times. For a craft that can fly and then dive, the structure and seals have to handle very different conditions. So when a witness says it went into the water and kept going, the question is not only about the object, the question is about energy. If something is moving at high speed and then enters water, it should throw up spray, create a loud impact, and slow down. If it does not, there are only a few options. The speed estimate could be wrong. The entry point could be far away. The object could have been something else, like a light reflection. Or, if the entry is real and the speed is high, the object is doing something unusual with the boundary between air and water. Many USO stories use the same phrases. No splash, no sound, instant turn, went straight down, hovered over the water, shot away. These are not physics terms, but they point toward physics questions. We will build those questions into a simple list. First, speed. How fast is the object said to move in air, and how fast in water? Second, acceleration. Does it start and stop as if it has no inertia? Third, transition. Does it cross the surface like a normal object, or like it is ignoring the surface? Fourth, signature. Does it have a heat trail, a wake, a sound, a radar shape? Fifth, control. Does it respond to other craft? Does it appear to watch or to avoid? Then we will look at cases that are often named as the strongest, and we will compare what they claim to what known physics allows. Before any case, we should state one rule. Stories can be sincere and still be wrong. A trained witness can still be fooled by distance. An instrument can still produce false tracks. None of that means the witness is lying. It means the world is hard to measure. Another rule is also true. When the same strange claim appears in different places, in different decades, with different witnesses who do not know each other, it becomes harder to dismiss as a single mistake. It may still be a repeating mistake. It may be a known effect that most people do not understand, or it may be something new. The ocean is a place where a new technology could hide longer than it could in the sky. There are fewer cameras, fewer observers, huge areas with no coverage. If someone had a craft that could move fast underwater, that would be valuable. It would change naval warfare. It would change intelligence. It would change shipping security. So the idea that someone would try to build such a craft is not strange. The question is whether any report suggests a performance that is far beyond the best-known submarines. To compare, consider what modern submarines can do. Exact speeds are classified, but estimates place fast attack submarines in the range of 20 to 30 plus knots underwater, sometimes more in short bursts. That is around 10 to 15 meters per second. A torpedo can be faster, perhaps 50 knots or more, which is around 25 meters per second. Some specialized supercavitating torpedoes have been reported at much higher speeds, but they are loud, leave a trail, and have limited control. They are weapons, not quiet craft. Now compare to some USO claims. Some reports describe objects moving underwater at hundreds of knots, or covering miles in seconds. That would be tens to hundreds of meters per second. In water, that is extreme. At those speeds, drag is intense. Power needs explode. Noise should be enormous. A wake or bubble trail should be seen. Unless, again, the object is changing the interaction with the water. This is where one term enters many discussions: cavitation. Cavitation is when pressure in a liquid drops low enough that bubbles form. If a propeller spins fast, it can create low-pressure regions. Bubbles form and collapse. That collapse can damage metal and creates noise. Cavitation is a limit for many underwater systems. It is also a tool for a special idea called supercavitation. Supercavitation is when an object moves fast enough and is shaped and sometimes vented with gas that it creates a large bubble around itself. Most of the object is then moving through gas, not water. Drag drops a lot, speed can rise, but control is hard. Steering in a bubble is not like steering in water, and the bubble itself is a signature. It can be detected by sonar and may create a visible trail. Supercavitation is real physics and real engineering. But a supercavitating craft is not silent. It is not easy to stop and hover. It is not easy to turn sharply. It is more like a bullet in a tube. So if a report describes a USO doing sharp turns underwater, or stopping and starting, supercavitation alone is not enough. Another term is boundary layer control. Every object moving through a fluid drags a thin layer of that fluid along its surface. The properties of that layer affect drag. In air, engineers use smooth surfaces, wing shapes, and sometimes suction or blowing to control the layer. In water, the same idea applies, but is harder because water is dense. If a craft could somehow create a very low friction layer, it could reduce drag, but it would still have to push water out of the way. A more extreme idea is some form of field propulsion. People use that phrase to mean many things, from magnetic effects to gravity-like effects. There is no confirmed public technology that lets a vehicle ignore inertia or ignore fluid drag by using a field. But there are real effects involving magnetism in conductive fluids, and those can be used for propulsion. One example is magneto-hydrodynamic propulsion, often called MHD. In MHD, you push an electric current through seawater while applying a magnetic field. The seawater contains ions, so it is a conductor. The forces move the water and the craft moves the other way. In theory, MHD can be quiet because there is no spinning propeller. In practice, it requires high power and large magnets, and it produces heat and chemical effects. It is not a magic drive. It is also hard to scale to very high speeds. Still, MHD is one of the few known ways to move underwater without a propeller. So we have a list of candidates for weird underwater motion that are still within known physics. Misjudged speed and distance, radar or sensor artifacts, optical effects near the horizon, fast object in air mistaken as underwater, supercavitation for straight-line high speed, quiet drives like MHD for slow, stealthy movement, exotic ideas that are not proven. Now we can move into specific cases. One of the most famous modern cases is the group of events linked to US Navy training near the coast of Southern California in 2004. Many people call it the Nimitz case. It is often described as an air case, but it has a strong water element. In the accounts of pilots and radar operators, objects were tracked moving in ways that seemed unusual. One part of the story involves a disturbance on the ocean surface. Pilots described a patch of churning white water, like something large was just below the surface. Above it, they saw an object, sometimes described as shaped like a white capsule or tic-tac. They described it moving quickly, with no visible exhaust, and reacting to their presence. If we limit ourselves to the water part, the key claim is this: something under the surface was creating a large pattern of disturbance, and an unknown object in the air was linked to it. There are a few ways to read this. 1. A submarine or other craft could have been below, and the disturbance was from something like a periscope wake, a surfacing maneuver, or a training decoy. 2. The disturbance could have been from a natural source, like currents meeting, a whale activity zone, or a patch of wind-driven whitecaps that look different from above. 3. It could have been from an aircraft or device entering the water. What makes it interesting is that multiple witnesses mention the disturbance, and they describe it as localized, like a single point of action. From a physics view, churning white water is usually a sign of energy transfer. It can be produced by propellers, jets, waves breaking, or large animals. If a submerged craft is moving very fast near the surface, it can create a wake. If it is turning or rising, it can create a disturbance. But the size matters. A small object cannot churn a wide patch without high power. The Nimitz stories are not clean lab data. We do not have a calibrated measurement of the patch size. We do not have the sea state recorded in detail in the reports most people have seen. So the physics conclusion has to be cautious. Still, the case introduces a theme. Many USO claims are paired. Aerial objects and underwater activity appear linked, as if one is a marker or the other. If a craft can operate in both air and water, it gains strong advantages. It can hide under the sea and then rise quickly. It can evade pursuit by diving. It can avoid the limitations of submarines by using the air to travel long distances and then using the water to hide. This is the transmedium idea. A transmedium craft can move between media, but the boundary is harsh. Air-to-water entry at speed should cause a big impact. A normal plane hitting water at high speed breaks apart. Even a missile striking water at high speed creates spray and shock. So a trans-medium craft that enters water without slowing would need a way to manage that interaction. One option is that it does slow, but we do not see it. Witnesses might see the craft at a distance, then see a splash, then later see a light underwater and connect them. That connection might be wrong. Another option is that the craft enters at a low angle and high speed and creates a spray that is hard to see from far away, especially at night. A third option is that the craft creates a cavity or a gas layer around itself as it enters, reducing the shock. This returns us to supercavitation, but applied at the surface. A fourth option is that the craft is not a solid craft, but a plasma or light phenomenon. This is often suggested for some UAP cases, but plasma in contact with water still creates effects. It would heat water, create steam, and create light scatter. So any no-splash claim should be treated as a strong data point. It is either wrong or it points to unusual interaction. Another often discussed case with a water angle is the 2015 period when US Navy pilots reported frequent encounters with unknown objects during training off the East Coast. These reports are more about the air, but some include objects near the surface. A pattern in these stories is that the objects are often seen in groups and that they sometimes appear to hover low over the sea. Hovering low over water is not itself strange. Many drones and helicopters can do it, but if the object is high performance and has no visible rotors or exhaust, it becomes strange. It also becomes a physics question about lift. To hover, you need to push air down or use buoyancy. A balloon can hover, but it drifts and is slow to control. A drone can hover by pushing air down. A jet can hover with thrust vectoring, but it creates heat and noise. So a silent hover is either a misread of sound and distance or something new. Now we shift into cases where the main claim is underwater motion. A classic type of USO report comes from sailors who see lights moving under the surface, sometimes keeping pace with a ship. These lights are often described as bright, sometimes white, sometimes green or blue. They sometimes appear to circle the ship. Some accounts describe them rising, diving, or splitting. What could such lights be? Bioluminescence is one option. Many sea organisms create light. In some conditions, waves and wakes glow. Some fish and squid also glow. But bioluminescence is usually diffuse and linked to water disturbance. Another option is a reflection of light from above, like a bright star or the moon reflecting off wave patterns. This can create the illusion of a moving light. Another option is human technology, like divers with lights, underwater drones, or submarines with external lights. But external lights are not common for military submarines in open ocean. Still, in coastal waters, it is possible. So when a report claims a light kept pace with a ship, we should ask, was the ship moving fast or slow? Was it day or night? Was the water calm? Was there a source of light above? Was the ship near a bioluminescent bloom? Many older cases fail this test because they lack detail, but a few have enough structure to consider. One famous story, often cited, is from the 1960s near Puerto Rico, linked to a US Navy facility on the island of Vieques. People describe lights entering and leaving the water with fast motion. Some writers connect this to the deep Puerto Rico trench nearby. Deep trenches are interesting for one reason. They are places where something could hide. But that is more a story argument than physics. From physics, deep water means high pressure. Any craft that operates at depth must handle pressure. A deep ocean craft like the bathyscaphe Trieste used thick structure and buoyancy tanks. Modern deep submersibles are carefully engineered. If someone has a craft that can dive thousands of meters, that suggests advanced materials and design. But there is a catch. A craft that can handle deep pressure is often heavy and slow. A craft that is fast and turns sharply is often light. Doing both is hard. So when a USO story claims extreme underwater speed and deep diving, it implies something far beyond current known design unless the story is wrong. Another often repeated case is Shag Harbour, Nova Scotia, 1967. In that event, witnesses reported a glowing object descending and hitting the water near the coast. People reported foam and a yellow light under the surface. There were searches. The case became a Canadian classic. If we stick to the physical claims, they are. A glowing object came down at a low angle. It contacted the water. A light was seen under the surface afterward. Foam or debris was reported. Authorities responded. This is closer to a conventional event than many stories. A plane crash, a meteor, or a flare could create light and foam. A meteor can be bright and can appear to descend. If it fragments, pieces can hit the water. But a meteor usually creates a large splash if a big piece hits, and it would not create a sustained underwater light unless burning material remained near the surface. A plane crash would leave debris, fuel smell, and would likely be traced. The Shag Harbour story remains debated because records are partial and accounts vary. From a physics view, one key detail is foam. Foam can come from wave action, but a sudden foam patch can also come from fuel release or from biological activity stirred up. So Shag Harbour is not a clear physics breaker. It is a case of an unknown water event with official response. The physics bending cases are the ones that include extreme speed, sharp turns, and no splash transitions. A modern case often cited is the 2013 event off Aguadilla, Puerto Rico, captured on infrared video by a US Customs and Border Protection aircraft. In that video, an object is tracked moving near the coast. At one point, it appears to enter the water and continue without obvious change. This case matters because it is instrumented. We have a video. We have location context. However, the interpretation is not simple. The video is from an infrared camera system that can create illusions of speed and size depending on range and zoom. The object could be a small balloon or a bird seen at a distance. The apparent splitting seen in some frames may be a camera artifact. Still, the water entry moment is what draws attention. If an object truly enters water at speed, we should see a thermal signature change as it contacts cooler water, a splash or disturbance, a deceleration or change in path. In the Aguadilla footage, we see limited detail. The object is small on screen. The sea state is not fully clear. Some analysts argue the object is likely a balloon drifting in wind, and the apparent water entry is the line of sight passing behind a wave, or the object moving into a region where contrast changes. Others argue the motion is too consistent and that the water entry is real. What can physics say? Physics says that small objects are very hard to classify in video without range data. A balloon can appear to move fast if the camera is moving and if parallax is misread. A bird can appear to hover if it is gliding. A distant object can appear to cross a shoreline when it is actually far out. So the strongest version of this case requires a full sensor package, not only the public video. Still, the case is valuable because it shows what a transmedium claim looks like on sensor. It is not a clear cut, but it is a template. Another water-linked set of events came from US Navy ships and aircraft in 2019 near the coast of California. Some reports mention objects moving near ships and possibly entering the water. One part of that broader cluster includes footage labeled USS Omaha, where an object is seen on night vision and radar, moving and then appearing to splash or submerge. This is often used as USO evidence. In that video, the object is a bright point. The splash is a brief flare and then loss of track. Again, the physics problem is that a point of light is not a craft outline. A light can be a distant aircraft, a drone, a flare, or a reflection. A splash could be a wave hit by a light beam, or it could be an actual impact. So once more, we are in the world of limited data. But the radar tracks, if accurate, matter. Radar can track objects beyond visual range and can provide speed. But radar has artifacts. Sea clutter can produce false targets. Adducting can bend radar beams. Strong temperature inversions can cause radar to see distant objects in odd ways. Ducting is a key ocean physics topic. Radar waves travel through air and are affected by humidity and temperature. Over the ocean, layers can form where air temperature changes quickly with height. This can bend radar waves like a lens. A radar can then see an object that is beyond the normal horizon, or it can see a reflection off the sea surface that looks like a separate target. It can also create ghosts, where a strong signal bounces between layers. So when someone says radar showed it drop from 80,000 feet to sea level, the question is whether the radar might be seeing different things at different moments. This does not mean radar is useless. Radar is one of the best tools we have. It means we need the raw data and context. Now, if we step back from named cases and focus on the physics claims, we can identify a set of bending behaviors that show up again and again. Behavior 1, extreme acceleration. If a craft goes from hovering to high speed in a second, the acceleration could be tens or hundreds of G. A human pilot would be crushed. A normal machine would have structural stress. Also, to accelerate a mass, you need force. That force would push against the air or water, producing a blast or wake unless the craft is using some other interaction. Behavior 2, silent, wake-free motion. A craft moving through air at high speed makes sound unless it is subsonic and far away. A craft moving through water makes noise from engines, pumps, and flow. Silent motion at high speed is hard. Behavior 3, right-angle turns. Turning at high speed requires centripetal acceleration. A right-angle turn at high speed is extreme. Behavior 4, no splash, no slow-down transitions. Crossing from air into water without a splash suggests either a very slow entry, a distant entry, or a method of reducing boundary impact. Behavior 5, deep diving paired with high speed. Deep diving requires strong structure. High speed requires low drag and high power. Doing both is hard. So what kind of physics would allow these? If we stay within known science, the most realistic explanations are not exotic propulsion. They are errors. Speed is misjudged. Distance is misjudged. A bird or balloon is misread. A flare is misread. Radar artifacts create false motion. But the existence of errors does not explain every detail in every story. Some stories include multiple sensors and multiple witnesses, so we consider other possibilities that are still within known physics. One is that a craft uses a bubble or gas layer to reduce drag in water. This could be a kind of super cavitation, but perhaps with better control than known weapons. If a craft could maintain a controlled cavity and steer, it could move faster underwater. It would still have to manage the cavity and would likely create noise, but it might be less than a propeller at the same speed. Another is that a craft uses electric propulsion in water, like MHD, to move without a propeller. That could be quiet. But to move fast, it would need immense power. Another is that a craft uses a combination. It travels in air using a system that is hard to see. It then enters water slowly or at a shallow angle to avoid splash. Once underwater, it uses a drive that is quiet and can move at moderate speed, not extreme. In that scenario, many of the physics-bending parts are illusion. The craft is not doing impossible things. It is doing clever things. This might fit a secret military technology. It might fit an advanced drone. It might fit a testing program. But some stories still imply more. If a craft can ignore inertia, then it is doing something beyond known engineering. In physics, inertia is tied to mass and acceleration. You cannot make mass vanish. You can reduce the felt acceleration if you spread it over time. You can reduce drag by changing how a fluid flows. But you cannot accelerate a mass without pushing something. So when people speak about anti-gravity or inertia control, they are describing an unknown mechanism. There is one more angle that is less exotic than it sounds. A craft might not be moving as a solid object. It might be a group of small objects that appear as one, or it might be a projection of light, like a laser spot on water. A laser can move across a surface faster than a plane can fly. It can stop and start. It can make right-angle turns. It can appear to go into the water if the beam changes. But a laser spot would not show up on radar as a solid target. It would also require a source. Another variant is electronic warfare. A radar system can be fooled by signals. A target can be created on radar where no object exists. This is called spoofing. Modern militaries invest heavily in radar deception. If a USO report is tied mainly to radar tracks, spoofing is a real option. It could also explain extreme acceleration and turns, because the radar track is not a physical craft. But spoofing does not create visual witnesses, unless the witnesses also see something like flares. So the strongest cases, in terms of hardness, are the ones where there is a match between different kinds of data. Visual sighting plus radar. Infrared plus radar. Multiple witnesses plus physical traces. Now we can return to a more careful walk through several popular cases, focusing on what is known, what is claimed, and what physics would require. We begin with the lights under ships pattern, because it is the oldest and most common. Throughout the 20th century, especially during wartime, sailors reported strange lights pacing their ships. In some cases, these were called foo fighters when in the air, but in the sea, they were just lights. During World War II, naval convoys faced submarines, mines, and deception. A light in the water could be a marker buoy. It could be a torpedo wake. It could be phosphorescent water stirred by a propeller. It could also be a trick of perception in dark water. Phosphorescence is a good example. Certain plankton glow when disturbed. A ship moving through such water leaves a glowing wake. If the glow is patchy, it can look like a separate object. Also, if a smaller craft moves near the ship, its wake can glow, and it may look like a moving light. So a WWW2 era report of a light pacing a ship is not strong evidence of a craft. It is evidence of a perception under stress. But there are a few cases where the pattern appears in calmer settings. In some reports from the Mediterranean and from parts of the Pacific, witnesses claimed a light moved under the ship and then shot away. If true, this is not plankton, because plankton cannot shoot away with speed. But the speed is often not measured. It is described as fast without numbers. If you are on a ship at night and you see a light in the water, your brain tries to place it. Without reference points, a light can seem to jump. So again, physics says, treat fast as vague until you have measured change over time and distance. Now, Shag Harbour. We can place Shag Harbour in a category of impact into water with aftermath. If a glowing object hit the sea and then a light remained, we can imagine several mundane events. A plane or helicopter crash with a burning component, a meteor with burning fragments, a flare drop, a fuel spill with fire on surface. Each has issues. A crash should leave debris. A meteor should not leave a stable light. A flare could, but then why the foam and reports of something moving? The best way to see Shag Harbour is as a case with real response and unclear cause. Now, Puerto Rico and the trench. A deep trench invites story. It suggests a hidden base, a hidden object, a hidden path. But physics does not care about story. Physics cares about evidence. If a craft uses the trench to dive deep, it needs pressure resistance. If it also moves fast, it needs drag control. So any trench-based USO claim is, by default, extraordinary. Now, Aguadilla. We can use Aguadilla to talk about a common misconception, that infrared shows heat in an easy way. Infrared cameras show differences in thermal radiation, but a cold object can show up bright if it is reflecting the sky, or if the camera is in a mode where contrast is inverted. Also, distance and humidity can change the image. In many IR systems, you can have a hot white mode and a hot black mode. A person watching a short clip can forget which mode is used and draw wrong conclusions. So when the Aguadilla object appears to enter water, the question is whether the contrast changes due to angle and background, not whether it literally went underwater. Still, the case stays popular because it is one of the few where the public can watch the event. Now, the idea of objects that split in video. In some UAP footage, a single bright object appears to become two. People sometimes interpret that as the craft dividing. In many camera systems, this can happen when the camera loses focus, or when the image processing creates a double blob. It can also happen when the object is actually a pair of lights close together, like two balloons or birds. So splitting is not strong evidence by itself. Now, the USS Omaha clip. This clip is used because it is paired with claims of radar tracking. If the object was tracked on radar and seen on camera, that is stronger than a camera alone. But we still face the same problem. A point of light is not a craft shape. It could be a drone, it could be a distant plane, it could be a flare. The splash is not clearly a splash. It could be the moment the camera line of sight meets the horizon and loses the object. So, to call it a USO case, we would need additional data. At this point, a person might ask, if all these cases have uncertainty, why take USOs seriously at all? The reason is not that every case is strong. The reason is that a few cases taken together show a pattern of claims about transmedium motion. And the ocean is the one place where a high-value technology could hide. So, rather than claim proof, a careful approach is to define what would count as strong evidence. Strong evidence would be a clear multi-sensor track of an object in air, entering water, then being tracked underwater. Speed and acceleration measured with known error bars. Physical traces like sonar returns that match the track. No plausible sensor artifact. We rarely get this full package, so the investigation becomes a problem of incomplete data. Now we move into the physics of the boundary itself. The air-sea boundary is not a clean surface. It is a layer of waves, foam, and spray. For a fast object, it is like hitting a shifting wall. If a craft enters water, the main shock comes from the sudden increase in density and the need to push water aside. The drag force in a fluid scales with the square of speed and with density. If density jumps by a factor of 800, drag jumps a lot. If a craft wants to reduce that shock, it can try to do one of three things. Reduce speed before entry. Reduce the effective contact area by entering point first. Reduce the density of the medium around it by creating a gas cavity. The third option is the most interesting for USOs. If a craft could carry a sheath of gas around it, it could move through water as if in air. But creating and maintaining a gas sheath at depth is hard because pressure collapses bubbles. A bubble at depth is squeezed. To keep it, you need continuous gas supply or strong fields. Supercavitation creates a bubble using motion itself. At high speed, a low pressure region forms and water boils into vapor. Gas can also be injected. The bubble is sustained by speed, so a supercavitating object wants to go fast. It does not want to hover. If a USO is said to hover underwater, it is not a supercavitating object, or the hover is misread. But some reports do not claim hover. They claim straight, very fast motion, like a streak under the surface. That kind of report could fit a supercavitating torpedo or a weapon test. This is a key point. Some USO stories might be secret weapons. If a Navy tests a fast underwater weapon, observers might see a light or disturbance and think it is a craft. If the test is classified, there will be no public explanation. So, in physics terms, the line between USO and classified weapon can be thin. Now we add another ocean physics factor: sound. Underwater, sound travels about 4 times faster than in air. Sonar uses this. A fast object underwater should create noise that sonar could detect, but the ocean is also noisy. Waves create noise. Ships create noise. Marine life creates noise. Also, sound bends in water because temperature and pressure change with depth. This creates layers where sound can travel far, called sound channels. It also creates shadow zones where sound does not reach. So an object could be near a ship and still not be heard if conditions are right. Or it could be heard far away. This makes sonar reports complex. Now we look at the idea of bending physics more directly. Many people use that phrase because the motion described seems to break Newton's laws. But Newton's laws do not break. If the motion is real, then there is a force causing it. The question is what that force is and how it is applied. In air, a craft gets force from thrust and lift. In water, a craft gets force from propellers, pumps, jets, fins, and buoyancy control. If a craft can accelerate without visible reaction, it may be pushing against the medium in a subtle way, like a distributed pressure field. But again, that is speculation. So we return to what can be measured. If an object appears to stop instantly, the most likely cause is that the observer lost track, or the object changed direction relative to the observer, making it appear to stop. If an object appears to move at thousands of miles per hour, the most likely cause is range error. A small object close by can seem to be a big object far away. If the range is wrong, the speed estimate is wrong. This is basic geometry. So any USO case that lacks range data is not a physics breaker. It is a story. That may sound dismissive, but it is actually a path to clarity. It tells us what to demand next time. Now we can propose a simple model of why USO stories persist. 1. The ocean creates mystery by limiting measurement. 2. Militaries test secret systems in ocean ranges. 3. People love the idea of hidden things underwater. 4. Some observers collect and repeat stories without checking. 5. A small set of cases with real unknowns keep the topic alive. Now we can take one more careful pass at the Nimitz water disturbance, because it is the most cited modern link between air and sea. If a disturbance was present, what could it be? A submerged object rising and pushing water up. A submerged object using a pump or jet. A school of fish driven by predators. A whale feeding event, wind shear creating a different surface texture. From above, these can look similar, but pilots often know the sea. They can judge whitecaps and patterns. If they described it as like a boiling spot, that suggests active mixing, not just wind. If there was active mixing, then there was energy. That could come from a craft. It could also come from an underwater explosion or test. But there are no public records of that for the exact moment. So, the best we can say is, the Nimitz case includes a reported surface anomaly that is consistent with an underwater object or event, but is not unique proof. Now, what about the concept of a craft using the sea as cover? This is a realistic strategy. A drone could travel above water at low altitude, using the sea as a background. Radar has trouble with low targets due to sea clutter. Visual observers have trouble because of haze. A drone could also land on water and float, or partly submerge to hide. It could then later take off. This is known engineering. It would not break physics. So some USO cases might be small drones, but this does not explain reports of deep underwater motion. Now we ask, are there any cases with credible sonar evidence of a fast object? There are many stories in books that claim sonar operators tracked unknown fast objects. Some mention fast movers underwater. Some mention objects that moved without propeller noise. But public documents are rare. One reason is classification. Another reason is that sonar data is complex and easy to misread outside the field. So again, the best public cases are video and radar, not sonar. Now we take the transmedium claim and examine it with a thought experiment. Imagine a craft shaped like a smooth capsule with no wings. In air, it could move like a missile or a drone. It would need a way to generate lift or to use thrust to stay aloft. If it is aerodynamic, it can use body lift at speed, but not at hover. So if it hovers, it needs thrust. Now imagine it enters water. If it is smooth, it can reduce drag. But without propellers, it needs a different drive. One possible combined system is a jet-like system in air and a pump jet in water. Pump jets exist on submarines. They are quieter than propellers, but they still create noise. Another combined system is electric fans in air and MHD in water. This is theoretically possible, but power heavy. Another is buoyancy control to sink and rise, plus a slow propulsion in water. None of these give instant turns, so if the tic-tac style object is real and does instant turns, it is beyond these models. But instant turns are the least reliable part of witness reports, because they depend on perception. Now we shift to a different style of case: coastal radar and police reports. In some coastal areas, police and Coast Guard have reported unknown lights that move over water, stop, and then drop below the horizon. Sometimes these are later linked to smuggling operations. Smugglers use fast boats and sometimes semi-submersibles. Some semi-submersibles ride low in water, with only a small profile above the surface. At night, with lights off, such a craft can be almost invisible. It can appear as a low, dark shape. If it carries a small light, that light might be seen as floating. So in some areas, USO reports may be linked to crime. This is important because it adds a real-world source of unknowns on water. But smuggling craft do not move at hundreds of knots underwater. They are slow and near surface. So again, this explains some cases, not all. Now we look at another factor: meteors and re-entry debris. A bright meteor over the sea can look like a descending craft. It can also fragment and create multiple lights. If fragments reach the ocean, observers might think it went into the water. If the event is at night, it can be dramatic. Also, space debris re-entry can create a line of lights that seem to move together. So some USO reports may be misclassified sky events. Now what about the reports of objects emerging from the ocean into the sky? These are also common. If a person sees a light on the horizon rise and move, it could be an aircraft taking off from a distant runway. It could be a helicopter. It could be a star rising due to clouds moving. It could be a satellite. It could be a rocket launch. So, in many cases, the ocean is not the source. It is just the background. This is why the strongest USO cases would involve a close-range event with clear interaction with water. So, to find the core of the topic, we should focus on the few cases that explicitly involve entry or exit and claim no splash. Aguadilla is one. Some naval accounts are another. There are also a set of older reports from Scandinavia known as ghost rockets in 1946, where objects were seen entering lakes. These are not sea cases, but they share the into-water theme. Many were likely meteors, so the pattern is broader than USOs. Now, we return to the word physics in the episode title. We should be clear about what physics can and cannot do. Physics can do: explain what should happen when an object hits water, estimate energy and drag for underwater speed, explain sensor artifacts like radar ducting, explain optical effects near the horizon, explain why certain claims would require huge power physics cannot do, identify the object without data, prove motive or origin, fill missing records. So the best we can offer is a map of constraints. Let us build a simple quantitative sense of underwater drag. Drag force can be estimated as F shuck 112, RHO, feeds 2s, CD, A, where RO is density, V is speed, CD is drag coefficient, and A is cross-sectional area. In water, RO is about 1,000 kilos per cubic meter. In air, ρ is about 1.2 kilos per cubic meter. So for the same shape and speed, drag in water is about 800 times larger. Now if an object is moving at 50 meters per second in water, which is about 97 knots, V2 is 2500. Multiply by RO and you get big forces. If the object has an area of 1 square meter and CD around 0.3 for a smooth body, the force is about 0.5, 1,000, 2,500, 0.3, 375,000 newtons. That is like the weight of about 38 tons. To maintain that speed, you need power P just F V, which is $375,000, 18,750,000 watts. That is about 19 megawatts. And this is for a fairly small object with only 1 square meter of area, moving at 50 meters per second. If you go faster, power rises quickly, because force rises with V2, and then you multiply by V, so power rises with V3. So a 100 meter per second underwater speed could require around 8 times the power, on the order of 150 megawatts, depending on shape. That is power plant scale. This is why claims of silent, fast underwater craft are difficult. You can reduce drag by changing CD and by reducing contact with water, for example, by supercavitation. If a supercavity reduces effective density around the craft, drag drops sharply. So supercavitation is one path to high speed with less power, but it creates noise and signature. So a craft that is both fast and silent would need a method not known publicly. Now we consider another claim, that some objects skip across the surface, as if the surface tension does not matter. Surface tension is small at human scale compared to the forces in high-speed impacts. It matters for small objects like insects, not for craft. For a craft, the issue is not surface tension. It is water density and wave shape. So if a craft skips without splash, it might be because it is not contacting water but moving above it, or the observer is far away. Now we consider heat. Any high power system creates waste heat. In air, heat can be lost by convection and radiation. In water, heat can be dumped into the sea. Water is a large heat sink, so a craft could hide heat better underwater. But if it is moving fast, friction also creates heat in the boundary layer. So a truly high-speed underwater craft would create heating, unless it is inside a cavity. Now this brings us to a reason some people connect USOs to weird phenomena. The ocean hides heat, hides sound patterns, and hides debris. It is a good place for unknowns, but hiding is not the same as breaking physics. Now we return to the popular phrase, went into the water with no splash. How could that happen? The entry was slow and at a low angle. The entry was far away and the splash was too small to see. The object was small. The object was a bird or balloon and did not enter at all. The splash happened but was masked by waves. The object was in a cavity and entered smoothly. If we accept the last option, then we accept that the craft has a method of controlling a cavity at entry. This is an engineering challenge, but not impossible in principle. Now we can consider a case that is less famous but common in stories. Objects that appear to rise from water in a vertical line. A vertical rise could be a helicopter. It could be a flare rising on a parachute due to wind, giving the illusion of vertical. It could be a rocket, or it could be a drone. So, again, the problem is classification. Now we come to the most important conclusion in the entire topic. When people talk about USOs bending physics, they are often using physics as a symbol for it seemed impossible. But the real physics lesson is that the ocean and the sky create conditions where human perception is fragile. So if we want to find real unknowns, we need to focus on the cases where perception is supported by instruments. And even then, instruments can be fooled. So the strongest path is multi-sensor. This is why the push in recent years for better reporting systems matters. If pilots and sailors can report with standardized data, future cases will be clearer. Now let us build a narrative of how USO ideas developed. In the early days of submarines, before sonar was common, the sea was already full of mystery. Sailors saw strange lights and shapes. Many were whales, storms, or floating debris, but the lack of tools made the unknown feel larger. Then, in the World Wars, submarines became real threats. Naval forces invested in detection. Sonar, radar, and patrol planes created new sensor layers. Each layer also created new types of false alarms. This is an important point. Better sensors do not only reduce mystery, they also create new ghost data. A sonar can hear a school of fish and think it is a sub. A radar can see ducting and think it is a fast craft. An infrared camera can see a distant heat source and think it is close. So the modern era is not free of confusion. Now, when we read a modern USO claim, we should ask, what sensor recorded it? What was the environment? What else was in the area? What is the simplest explanation? This does not end the mystery, but it reduces noise. Now we take one more look at transmedium from a physics standpoint. If a craft can cross the boundary at speed without splash, it might be using a method that reduces pressure on the water. One concept sometimes discussed is a field that pushes water away, creating a low-pressure region. But there is no known field that can do that at range without huge energy. Another is that the craft might create a layer of gas, like a torpedo that injects gas at the nose. In principle, an air-breathing craft could carry compressed gas and release it at entry to create a cushion. But then the craft needs to switch to underwater propulsion, so a practical transmedium craft would be complex. This is why many analysts think that if such a craft exists, it would be a major breakthrough. Now, we can speak about the bending part in a more grounded way. The most realistic way a craft could appear to bend physics is if it uses sensor deception. If a radar is spoofed, the track can show instant turns and extreme speed. If the spoof is paired with a visible light source, like a drone or flare, then witnesses might think they saw the craft that matches the track. This is similar to how decoys work. You create a false target and you distract the observer. In naval warfare, deception is normal. So, a skeptic can argue that some USO events are not craft at all, but training or adversary deception. A believer can counter that this still implies advanced capability. Either way, the ocean remains the stage. Now, we can build the case list that most people mention when they talk about USOs. Shag Harbor, impact into water. Puerto Rico, Vieques area, lights, alleged entries. Aguadilla infrared, apparent water entry. USS Omaha, Pacific encounters, apparent submerge. Nimitz disturbance, surface anomaly, linked to UAP. There are many more, but these are enough to explore the physics claims. Now let us take the idea of objects moving underwater at aircraft speeds and test it with numbers. Aircraft speeds are often hundreds of knots. A typical jet might cruise at 450 knots, which is about 230 meters per second. If something moved in water at 230 meters per second, drag would be huge. Even with a cavity, control would be hard. The shock waves in water would be severe. It would be like a torpedo on steroids. So, if a report claims such speed, it is either wrong or it describes a weapon test. Now, another claim is that some objects drop from air into water instantly. If a radar track shows a target at high altitude and then at sea level, it could be a tracking error. It It could be a different target, or it could be a radar mode change. So, radar alone is not enough. Now, this may leave the listener with a feeling of unresolved mystery. That is honest. USOs are a topic where the public record is thin, but there is still value in mapping what would be required. So we end by stating the simplest physics-based conclusions. First, the ocean makes measurement hard. Many USO reports can be explained by misjudgment and sensor artifacts. Second, fast underwater motion at high speed requires huge power unless drag is reduced by a cavity. Third, supercavitation is real and could explain some straight-line fast underwater signatures, but it does not explain silent hover and sharp turns. Fourth, a true transmedium craft that crosses the boundary with no splash and no slowdown would require a method of boundary control that is not known publicly. Fifth, if such a craft exists, it would have major military value, so secrecy would be expected. Sixth, because of that, the best path forward is better data, not louder arguments. As long as the sea stays dark, the stories will continue. There is one more detail that often gets missed when people talk about underwater impossible motion. The sea is not a uniform tank. It is layered. Temperature, salt, and pressure form gradients. These gradients change how sound and even light travel. A sharp temperature change with depth is called a thermocline. Above it, water can be warmer. Below it, colder. Sound speed changes with temperature and also with pressure. When sound speed changes, sound bends. A sonar operator might hear a contact that seems close, but the sound could have traveled along a curved path. Or a loud event might be hidden in a shadow zone. This matters for USO stories, because some reports claim sonar did not hear it, as if that proves silence. In real ocean conditions, sonar can miss real objects. It can also create contacts that are not objects. It depends on frequency, sea state, and the sound channel. If someone ever releases a strong USO case with sonar, the first question should be whether the conditions were logged. If the thermocline was strong and the unknown was below it, detection could be harder. That does not prove anything about exotic propulsion. It proves that the ocean is complex. Another detail is that many people imagine the ocean's surface as a line on a chart. In reality, it is a moving field of waves. In high sea states, a splash can vanish inside the next wave. In low light, a splash can be invisible even at moderate distance. If a craft entered water at night, a witness might see a light drop to the horizon and then disappear, and later describe it as entering water with no splash. So when you hear no splash, it is useful to pair it with a second question. How good was the viewing geometry? Was it daylight? How far away was it? What was the sea state? Was there moonlight? Were there other reference points? If those details are missing, the claim is weaker. Still, the topic stays alive, because a few reports appear to be close range, and because the ocean is a place where unknown technology testing is plausible. If we treat USOs as a technology problem, the most realistic, advanced underwater craft within known physics would aim for these goals. Reduce acoustic signature, less prop noise. Reduce radar signature at periscope depth. Reduce wake on surface, maintain moderate underwater speed while staying quiet. Use small size and low profile. None of that requires breaking physics. It requires good engineering. Now compare that to the viral claims. Hundreds of knots underwater, instant stops and turns, no wake, no heat, no sound, direct air-to-water entry at speed with no effect. Those claims jump far beyond what we can explain with better propellers and better coatings. They move into a different category. So a disciplined approach is to divide the cases into two bins. Bin 1, cases that might be explained by known effects, errors, or secret but plausible engineering. Bin 2, cases that, if accurately reported, would require a new method of motion. Most public cases sit in Bin 1. Bin 2 is where people place the strongest version of transmedium claims. If that bin contains anything real, it would be a breakthrough. But until we have clean data, Bin 2 remains a question mark. So the best ending is not an answer, but a standard. If someone wants to claim a USO bends physics, the report should include sensor type and settings, range estimate and error bars, time-stamped track data, weather and sea state, multiple independent measurements. Without those, we are mostly reading the ocean the way ancient sailors did, by impression. And the ocean is skilled at creating impressions. This was a quiet archive story, where the story ends, sleep begins,